Hello students and welcome. We're going to be going through some proof reasoning with pictures and mostly just kind of drop down fill in the blank, but this is to try and help you trace through how to identify the parts in a picture and what would make sense as a reason to say those two things have a relationship. All right, so in each of these, your first statement, your first reason should always be given, because it's just restating the information that you were given. And what you'll notice in the picture here is that these marked things are trying to show in the picture these things that are listed in the given. All right, now let's check this next one. It says angle B is equal to angle D. That means these two right here. And whenever you have parallel lines in a Z shape, that will give you alternate interior angles. So that would be this one here. It says alternate interior angles. And those alternate interior angles are congruent with parallel lines. So this is a very abbreviated reason, but it's still sufficient enough. All right, next we have these angles in the middle that say angle AEB and CED. Those are vertical angles. So I'm going to look for something that references vertical angles. And there we go. Now that I have those red angles marked, the blue angles marked, and these given sides, that gives me a pattern of congruence for the two triangles. And what I'm looking for is something that has two angles, but the side, let's zoom in a little bit closer here. I have two pairs of angles, but this more pink looking side that's marked is not between the two angles, but instead it's away or across or opposite one of the angles. That means it'll be the angle side pattern. All right, let's do another proof. We have some things are congruent, and we want to prove that DB bisects ABC. So what we want to finish with is this middle vertical line is going to cut the total top angle into two equal pieces. All right, so we start with given, like always. This next line, it shows that something is equal to itself. And whenever you are equal to yourself, like in this picture, this line down the middle there, that's like seeing a reflection of yourself. So we call it the reflexive property. That actually gives us enough information already to jump to congruent triangles. And we have one pair of sides marked, two pairs of sides marked, and the third pair of sides marked is the side that overlaps itself. So that gives us side, side, side congruence. Now that we have congruence, we could say that any other part of the triangles would be congruent. So we have ABD and CBD. So I actually need to move these angles up here and here. So that should have been ABD and CBD. And so we'll say that those are, because of this corresponding parts are congruent because the triangles are congruent. That's also referred to as CPCTC. It's kind of a mouthful, but it's basically saying that when you have congruent triangles, you can say all the parts are also congruent. Now that we know that those are congruent, these two purple kind of zones here, those two angles, that is an angle bisector. So an angle bisector is just saying that it has a segment splitting two angles into two equal pieces. And because we know they're two equal pieces, we can use that reasoning in reverse as well. All right, let's look at another one. We have given stuff. This gives us some perpendicular lines, so it's going to say these two edges here, AB, BC, and these two edges here, AD and DC, are perpendicular, so that's going to give us a little bit of information about those angles. So number one, that means that perpendicular leads to right angles, but also that tells us that certain triangles are right triangles because right angles go with right triangles. For this next one, ooh, I recognize this. We have something equal to itself, like looking at yourself in the mirror. That's a reflexive property. That's where that line down the middle is equal to itself. Okay, at this point, we do have enough information because this purple angle in each of those corners is a right angle. And then we have this side and what would be called the hypotenuse because it's across from the purple angle. That gives us a combination of hypotenuse and leg. Now this has one additional layer on here, and it's saying that these angles here, BAD and DAC, are equal to each other. So that would be like those two gray angles right there. And that's true because of that long phrase, corresponding parts are congruent, because triangles are also congruent. I'm going to make a little bit of a change here to this. Those are congruent because triangles are congruent. There we go. And we'll save that up for all of things. Corresponding parts congruent because triangles are congruent. All right, now let's look at this. We're already almost fully done. We're about halfway or so. This one just has 4 steps here. Let's see what we have. The two triangles are congruent, so they're kind of giving us a pair of triangles already. Let's see if I can trace these shapes for us. So it's talking about this triangle ADE. So that blue triangle, they're saying, is congruent to this other triangle over here. I'll flip it around. We can rotate, flip it horizontally. So those two blue triangles are congruent. I'll delete that for now so we can see the letters and other information a little more clearly. And that is just simply given. Well, because we know those kind of wing triangles are congruent, that means all the other parts of those triangles are congruent, including these two angles, like D and C. So we'd say that long phrase, corresponding parts are congruent because triangles are congruent. Similarly, we could say that this side AD and this side BC, for the same reason, corresponding parts are congruent. So matching pieces are equal by themselves because the whole triangle is equal as well. All right, now we have enough information, kind of in a weird way. Or do we need one more thing? I think we actually need one more thing that's missing. Let's see. We have that those two angles are congruent. And we have that these two sides are congruent, AC and, oh, no, we have enough. So that side with that angle and that side, that gives us a side angle. Is that right? Well, that wouldn't necessarily work. We would need one more side. So I'm going to add something to this. And in your video, it'll already be there. Actually, we can just substitute it out from this one here. So in this, we would be looking for angle, or not side angle, but side AB is congruent to itself. And this is not a corresponding parts, but this would have been reflexive. So we'll have this fixed in your notes, that you can put this in here. Let's see if I can copy and paste this other drop down, bring it here, and change this to reflexive property. So what that is saying is that down here, this piece there is equal to itself. So I'll click on that. We'll make it yellow so it kind of matches the reasoning. There we go. So that is also true. And if that's true, I'll grab that to copy and paste it onto the next drawing. That gives us that we have a side and a side and another side. So we would have side, side, side congruence instead of the angles. So delete this row. And so we're going to have side, side, side congruence with that. There we go. All right, let's look at this next one. It's kind of split across a couple of pages, so we'll start a brand new page for it. And we got 2 more to go. This one that we're on, and then the last one. This one has a lot of parallel lines. So when you have parallel lines, you wind up getting these Z shapes. So first step given. Let's look at the second step. So I'm going to focus on like the circles, those 2 circles. These fit together in a Z shape, like a backwards, sideways Z. And then the 2 square angles, those also are in that Z shape. Whenever you have that pattern, that is an alternate interior angles. I'm going to change these colors. I'll do it for the students as well, but the reasoning is blue, so we're going to make this a blue color so it matches that alternate interior angles color. Now we have that the middle line is equal to itself. AC is equal to AC. Anytime you're equal to yourself, that's going to be a reflexive property. The only thing I'm going to change here is these colors back to blue. You guys will have it changed already on yours, so you don't have to worry about it. That gives us enough information to say that we have congruent triangles because I have angles that match and a side that matches. So that's going to be my angle, side, angle, because the side is between the 2 angles. It's not opposite up here or down here. Now, once we have 2 congruent triangles, we can actually say that matching segments would also be congruent. So that's saying AB and CD are congruent because that long sentence of corresponding parts are congruent because triangles are congruent. All right, we're on our last one. Let's start out with a given. That's our given information. Now we have our next piece of marked information. It says BCA is congruent to CAD. So BCA and CAD, that's a Z shape with parallel lines. That's going to be my alternate interior angles. Again, I'll change these colors. They were supposed to match with the blue of the alternate interior angles. And one more time, we have the same kind of thing where we have a reflexive property on this overlapping side in the middle. So that's the reflexive property, like a reflection of yourself. This gives me enough information because I have 2 angles and a side, 2 angles and a side, and the side is not in between the angles, but instead it's kind of opposite these green angles. So that's going to be angle, angle, side. And now we've chosen reasons to kind of fit all of our proofs. And that's all we have for this. Good job.